When we get to dissolved oxygen content in water, will be another one of those. The predator effect may be one of those. Demographic transitions is one of those, and this is right up there. This might be the hardest because a lot of kids get confused by the lingo. In order to keep everybody's attention, pace with the look up here, listen to this, copy that, I'd like everyone to please write as much as you can read of this reaction. If there's something you cannot read, please just skip it and I'll give you the words in the lecture part. But you will need this graphic, and then I'll put on the screen a slightly cleaner version of this graphic. Then we'll label them in lecture. I'll give you about 4 minutes to copy. Tyler Halfdog, Daniel Feinberg, Leanne, Mimi Banks, If anybody doesn't need these graphics, I guess it's your funeral, but please don't distract the students that are trying to copy. And if you'd like, on the screen, I have a slightly tidier version of my crappy drawing on the board. You'll need this and that, and you're going to put a lot of writing, so you might want to make them large.
Is that online?
I'm sure you can find these on the internet, but our PowerPoint in Unit 7 is too big to put on the web.
What would this be called?
A pressurized water reactor, and I'll talk about this. Is what? If there's words you can't read, we'll fill them in later. Word?
The MN coming from the
MO 103. Molybdenum.
Just going to be out there at the end of the period.
I will try to leave these things on the board for at least a couple of days, but I'd strongly encourage you to start with this foundation because you're going to be writing on top of that during the lecture. You've used 2 of your drawing minutes. You have 2 left. I assume you'll be able to continue writing or continue drawing while I speak in class. But I think I'm going to start with some words now. First of all, some things we discussed last week. Last week, in case you don't remember these things, we talked about the composition of the atom, its neutrons, protons, and electrons, their relative charges. Protons positive, electrons negative, neutrons neutral. You may remember that the atomic number is the number of protons. That's the thing that gives the elements their identity. Electron numbers come and go. Elements can be ionized, and then they can come back to neutral, then they become the opposite ion. Electrons come and go. But neutrons, when they vary, are called isotopes of an element. And remember that most isotopes are naturally occurring. In some cases, humans can do a lot of extra work to change an isotope into another. Now, the first concept that I want everyone to master is the idea of enrichment. Raise your hand if you've heard that Iran is an international hot water because of their enrichment efforts. Okay. We'll come back to discuss why that is kind of scary, but kind of not that scary. We'll talk about that. First thing I want to tell you is over here. In nature, there are two naturally occurring isotopes of uranium. They are uranium-238 and 235, and please look at the whiteboard. That number is called the atomic mass. It's basically the weight of one atom in atomic mass units. Please look up. Uranium-238 has 3 neutrons more than the other naturally occurring isotope of uranium, uranium-235. In nature, 238 is 99.28%, 235 is 0.72%. When you find it in the ground, uranium ore has those percentages. A few things about uranium. First of all, you'll notice that 235 is rare. Just so that we're clear, uranium itself is not. Anybody know how much an ounce of gold weighs today?
An ounce of gold weight.
Costs. I'm not that smart, but at least I'm good looking. Yeah, an ounce of gold today costs, I believe, $1,700, give or take a couple hundred. So a pound being, what, 16 ounces? Would be like 17 times 16 is like 30 grand. Anybody want to guess what a pound of uranium weighs?
A pound?
Cost. I totally meant to do that. Just trying to make sure you're awake, you know, I'm a master instructor.
No idea.
$6 is what a pound of uranium costs. Oh. Yeah, uranium weighs costs $6 a pound. $6 a pound. That's cheap. The point I'm trying to make is uranium is common. You know, we make uranium into like plumbing. It's actually really common in like pots and pans. I know, but I'm not kidding. Uranium is pretty bland. Uranium is one of the most common ways to make bombs because it's really heavy. Not because it's radioactive or explosive, it's just simply heavy. I reckon that they probably do add it to some specialized bullets, but we make bullets out of stuff that's even cheaper than this. the reason that we make bombs out of uranium is if you look here, there is no element heavier naturally occurring on Earth. So if you're going to drop something on an enemy inside a cave and you're hoping to break the rock, bunker buster bombs are made of uranium. Not for its radioactive properties, just because it's the heaviest thing we can find. Breaks rocks. You ever heard of bunker busters? They're just a heavy bomb. Like, it just weighs more. If bricks were the heaviest, we'd be dropping bricks, but this is way heavier than a brick. Now, as I said, uranium-238 is pretty mundane. All things considered, it's all over Carpinteria. It's pretty common in your rock in Carpinteria. If you live in Summerland, you can probably pull up a little piece of uranium in a hole in your backyard.
Can you buy it?
I reckon.
Yeah, you can buy uranium.
That's really sick. Dude.
Now remember, uranium, I'm going to point at it again, is almost completely the mundane variety, and a very small percentage is what we need for nuclear energy, the cool stuff. So, it's actually, you can make it unstable. It is itself stable.
Oh, okay.
Watch me though. If I've got this much, no, not there, just the head. If I've got this much uranium-238, and a little fleck here, and a little fleck there, and a little fleck here is the good stuff, we have to enrich it. The details of enrichment are carefully guarded national secrets that I'm not privy to, slightly above my pay grade. But the concept is simple, and I think you understand that things which are heavier fall through water faster than things which are light. Everybody know that? So, watch me. You take a big chunk of uranium ore, you grind it up into a powder, you put the powder into a special liquid, and then you spin it really fast in this thing called a centrifuge. And the stuff that goes to the bottom of the tube first will be uranium-238. It's heavier. And the uranium-235, because it's a little lighter, will be in the upper layers of that test tube. So you take it out of the test tube, you cut off the bottom, throw that out, grind it up again, spin it, take the stuff out of the bottom of the tube, cut the bottom, which is the heaviest, throw it out. And if you keep doing this over and over and over and over and over in like a gajillion centrifuges, you have, quote-unquote, enriched uranium. When that rare stuff has become relatively more common, like 3%. That's what we call fuel grade. This is uranium enrichment. This, as far as I am aware, and as far as the international community has discussed openly, this is as far as Iran has gotten. Just so that we're all clear, weapons-grade uranium is much more enriched. Anybody have a smartphone? Percentage U-235 weapons-grade. I think it's about 90%. Just so you know, this is what I'm saying about the Iran issue. I mean, I will be the last person to defend the current president of Iran. As far as I can tell, I believe his last name is Ahmadinejad. As far as I can tell, that guy's nuts. He's
about 90%.
Yeah. As far as I can tell, that guy's a total nutcase. But I kind of hate it